All right, pirates. Welcome to the next session of notes for ionic compounds, Unit 2. And so, two things you're going to always want to download and always want to have available whenever you're doing ionic compounds for the whole rest of the unit, maybe even the whole rest of the year, is your periodic table. So, I just downloaded this from my Schoology page. And then this common ions list. This can be found on page 3 in the Unit 2 packet, Part 1. Okay, so these two things will help you through just about everything we're going to be doing during this unit and actually a couple of the future units as well. So you're always going to want to be downloading that, uploading that into your notes for the duration of this unit. So let's talk really briefly about polyatomic ions, what they are first. So we have poly. So if you remember back in bio, we worked on prefixes and we talked about breaking words down to figure out their meaning. And back then, we discovered that poly, as in polymer, poly, just means many. It means more than two. So poly means many, and so really many atomic ions, that's what we're talking about here. What these are is these are ions made of more than one atom. And I'll say more than one atom type. Right? Previously, you were working with just one atom type, so you could have NaCl as just sodium, and then just chloride or chlorine or the chlorine ion, chloride. Or you could have, for example, calcium chloride, in which case you have calcium and then Cl2 as the anion. Well, in polyatomic ions, we're going to combine multiple atoms. All right? So where do we find these polyatomic ions? Well, there's a couple places, but this chart right here gives you an idea of all of these polyatomic ions. Now notice that most of the polyatomic ions, they're anions. Most of the polyatomic ions have negative charges, although there is one exception on our chart, on our common ion chart, that you need to know for this class, and that's ammonium. There are others, but ammonium is the main one you guys need. And so look at all these polyatomic anions because they are made of more than one atom. We have hydrogen, sulfur, oxygen, hydrogen, phosphorus, oxygen. These are all of your polyatomic anions. There is one exception that you need to know, and that is ammonium, and ammonium has a +1 charge. All right, so you have one polyatomic cation that you need to know, and then a whole bunch of polyatomic anions. So they can take different charges. Notice that some of the charges are -2, some of the charges are -1, some of the charges can even be -3, and you don't have to memorize that. You just need to know where to find this, and the more you use it, the more you're going to accidentally memorize it. So keep in mind that, okay? So they are usually anions. And as you remember, anions are a negative ion. They take a negative charge. All right, so polyatomic ions. First thing we're going to talk about really quickly actually is naming, because the naming rules for polyatomic ions are very simple. Okay, most of the anions end in 8 or 8. So what you'll notice is if you ever see an ionic compound that ends in 8 or 8, you're talking about a polyatomic anion. Because notice up here we have a bunch of ions. We have acetate, carbonate, bicarbonate, chlorate, chlorite, chromate. Here is one exception. One exception is cyanide. That's an exception to the rule. Cyanate, dichromate, dihydrogen phosphate, hydrogen phosphate, sulfate, and you get the idea. All right, so all of those compounds end in 8 or 8. The major two exceptions that you guys need to know, and there are multiple exceptions, but the two main ones that you need to know for this class are hydroxide, which is ends in ide, and then cyanide. Those are the two that we will use frequently in this class, and although there are others, those are the two that you're going to want to focus on for this class. Okay, just deleting this a little bit, make it a little bit clearer for you. Okay, so let's talk about naming. Naming is very simple and very straightforward. You write the name, and you just write it as is. Very simple, very straightforward, right? So you don't have to worry about changing any endings. You don't have to worry about transition metal charges. You just write the name of the ions as is. So for example, if I have this NH4Cl and I have this over here, I have, let's say, CaCO3 or even Na2SO4. Okay, so what you're doing is you just have to look up the cations and then the anions. I'm going to do the cations in blue, cations in blue, cations in blue. I'm going to do the anions in purple. So anion and anion. So all you do is look it up and name it, right? So here we have NH4, that is a polyatomic cation. So we go up here and we look and we see my NH4 right here is ammonium. So what I'm going to do is I just write down ammonium. I don't need to change anything. And then I'm not going to get into the nitty-gritty of how to name the Cl, but that is a monoatomic, meaning made of one type of atom, and that is chlorine, and you always drop the ending for a monoatomic, and that becomes sodium or ammonium chloride. Okay, over here, the next one, we have calcium, right? It's on the periodic table of the cations. You just name as is. So calcium is from the periodic table. If you need to look at the periodic table, we have calcium right there. All right, and calcium, and then we have a polyatomic anion in that case. We scroll up to our polyatomic anions. They're kind of in alphabetical order by name, which means they are somewhat in alphabetical order by the elements. And over here we have CO3, which it matches up with what we have down there, and so that is named carbonate. So we come down to the bottom there, and we name it calcium carbonate. Okay, once again, I'm going to resize it a little bit and put that underneath. So calcium carbonate, all you're doing is naming the ions. You're not worrying about subscripts other than matching those subscripts. Over here we have sodium. Sodium is on the front of the periodic table. It is a cation. Sodium is right here in group 1, row or period 3, sodium. And then we look up the anion, which is SO4, and we find the SO4, which is down here, sulfate. All right, so we just name it as is. Can't get much simpler than that. Calcium sulfate. And then I'm going to take my scissors and I'm going to resize it to make it look nice and neat. So that's all you're doing. You're looking up the ion on the polyatomic ions list or the common ions list, and you're just writing the name. You're not changing anything. You're not doing anything fancy, and you always just name the cation, so you don't need to worry about that. All right, so formula writing is where it gets a little tricky. Okay, and the reason why is because you have to worry about subscripts. Okay, so you've already done crisscross, you've already done matching up and actually doing the long form way of writing things. But let's say I have a compound such as magnesium and nitrate. Okay, so what we have to do then is, just like in the other sections, we look up the ion for magnesium. We find ion magnesium. Here's magnesium right here. We look at the charge for magnesium. It has a +2 charge. And so we write our ion here, Mg +2. Okay, and now we look up our anion. Now this is a dead giveaway that it is a polyatomic because it ends in 8. So that means we need to go to our common ions list and we look up nitrate, and you get NO3 -1. All right, so I write down my NO3 -1. So now we're going to double check. Can we just write it as is? Do these charges cancel out? Are they equal and opposite? No, they're not equal and opposite. A 2 does not equal a 1. So we can do one of two things. We can either make our little table chart and we can write out, okay, well, right now I have a +2 on the left side. I only have a -1 on the right side. So I'm going to add another minus, a whole NO3. You have to add the whole package. You have to write the subscripts exactly as is. You have to write the charges exactly as is. And so you can do it that way. Now my charge is balanced because a -1 and a -1 gives me a +2. So now I have a, or sorry, not a +2. I have a -2. So they balance out that way, +2 and a -2. Or you can do the old-fashioned crisscross method, which is Mg +2, NO3 minus 1, and then you bring down the 1, negative 1, and you bring across the positive 2, and you end up writing your two ions like this. Now here is the issue. If I bring down my negative 1, I don't need to write it because it's just a 1, but if I bring down my 2, you need to be very careful, okay? Because I can't just bring down that 2. Because otherwise it's going to look like it says 32. Or I can't just multiply that 2, right? I can't just do this, have NO6, all right? Because look, if you look over here, these are both wrong. That's wrong, that's wrong. Because if you look over here, if I have this NO6, if I just multiply it by 2, just that oxygen by 2, notice over here we have 2 nitrogens, but over here I only have 1. Okay, so you can't do that. So here's where the formula writing gets tricky. And where the formula writing gets tricky is in order to show me that I have 2 of those compounds, or 2 of those ions, what you need to use is you need to use parentheses. So whenever you have more than one, whenever you have more than one cation of the same type or more than one anion of the same type, you need to put parentheses around it. What this is saying is I have 2 of everything inside those parentheses. I have 2 nitrogens and then 2 times 3 oxygens, the distributive property, just like for math, right? So let's do another one, another example, and this is a commonly mistaken one. You got to be very careful of these when you are working with hydroxide, for example. So what we have here is we have aluminum and hydroxide. Okay, and so what we do, we look up the cation. Cation is not one of these, it's not one of these, so it must be on the periodic table. There's my aluminum, there's the charge. I have aluminum plus 3, so I come down here and I write aluminum, Al plus 3, and then hydroxide. Well, ides usually are on the front of the periodic table, so this is why you need to practice your stuff, because if you don't practice it, you're going to be spending forever looking for hydroxide on the front of the periodic table. But remember, hydroxide is one of our exceptions to the rule. Hydroxide is right here. Hydroxide is OH minus 1. So that's why you need to practice your stuff so you don't waste time. Okay, so I look up hydroxide and I get OH minus 1. Now these charges are not equal and opposite, so I'm going to crisscross, right? So I take my 3 and I bring it down. I take my 1 and I bring it down. So I don't need to write the 1, right? I don't need to write that. So I just write Al. Okay, now when I bring down the 3, I need to be very careful. A lot of you are going to just write that, but that is incorrect because I actually have 3 of the hydroxides. I have 3 of the whole thing. So I need to make sure that I include my parentheses, and that tells me that I have 3 of all of those atoms. So make sure that whenever you have more than one, you need those parentheses. Now let's do another one. Let's do ammonium and a carbonate. All right, so I look up on the periodic table, I look for ammonium. Once again, this is why you need to practice, because if you remember, ammonium is a polyatomic cation. So polyatomic cation for ammonium is NH4 plus 1. Okay, I look up carbonate. I know that it's a polyatomic because it ends in 8. So I find it over here, and I get carbonate right here, CO3 minus 2. And so I write that down. I write down CO3 and then minus 2. Okay, now I do my crisscross method, right? I bring my crisscross method, bring it down, bring it down. And so I now have my NH4 with my 2, but remember I need parentheses because I have more than one of that whole polyatomic, and then I bring down the 1 to carbonate, so I would need parentheses, right? Except I only have one of them. So it's kind of redundant to write those parentheses, so whenever you have a polyatomic that's only one of them, you do not write those parentheses down, you just write it as is. And so ammonium carbonate then is NH4, 2 of those whole NH4s, and then CO3. And that's it. All right, just takes practice. It's simple, but it's only easy if you work at it. Okay, pirates, let me or your teachers know if you have any questions. Please, thank you for viewing, and I'll see you soon. Bye, pirates.